Hello, welcome to our video on the design and construction of the Blue Comet. We are a team of 13 undergraduate fourth-year mechanical engineers at the University of Virginia and are excited to showcase to you what we worked on all school year. This is the first year our school was to be represented in the competition, and we were thrilled to compete in East Lansing. Building the Blue Comet was a wonderful learning experience, so here's a look at all that we accomplished and learned.
Blue Comet was designed as a three-wheeled tadpole recumbent truck constructed from ARSI 4130 steel. The boom provides the main structure for the vehicle with a symmetric axial and rear fork splits. These features are highlighted in red. As shown in blue, an integrated rollover protection system increases the rider's safety in the event of a crash. We designed an extension rod for the crankside with 7 inches of adjustability due to having different rider heights. A removable transparent partial fairing is applied to increase the aerodynamic efficiency in the drag race while not compromising visibility.
The timeline for the project was split into 2 phases, which correlates to the fall and spring semesters. Our initial step was to conduct research, which was done by looking at HPVs entered in previous competitions, along with looking at recumbent bike forums for more details. The research phase of the project was completed by October 7th. Then we moved on to design and analysis, which was done using SolidWorks. An initial design was created by November 25th, and then we did testing, which includes FEA and CFD testing to look for areas of improvement. With the data, we were able to create a final prototype on SolidWorks by January 20th, 2020. Once we had our design and were waiting on the parts we ordered, we began to do some shop training, which gave us more experience working with tools prior to the start of the build, since we had little prior experience. Once the parts came in, we began to build the bike, starting off with the frame and rollover protection system, then moving on to parts such as the steering and wheels, which will be discussed in the next slide.
As seen in our progress video, our team had assembled a majority of the main components of our trike. We had completely finished all the welding of the frame and had the seat fully attached. Our fairing, which is not shown in the video, was fully assembled and ready to be placed on the trike. Additionally, we had installed the adjustable crankset and the wheels in preparation for chain path routing. The steering mechanisms was the last main portions that had to be built and installed.
So since this was our first year participating in this competition, we didn't really have a good sense of what to expect in terms of cost. Tracking these costs and maintaining a good budget was especially important to us. We were fortunate enough to secure funding from 3 different sources here at the university, adding up to a total of $6,500. So our total expenses up to this point are $3,250, and the remaining amount from our initial budget consisted of vehicle and rider registration costs, hotels, transportation, etc., all of which have been refunded. So taking into account all of those expenses, we still would have had around $700 remaining at the end of the competition.
After winter break, we learned several building skills, such as using the lathe, notching, bending, and welding. Our welder took several weeks to train her welding skills. We verified our welder's skills by testing the strength of her welding samples. During manufacturing, we found adjustments that needed to be made. First, we changed the angle of the roll cage to ensure the rider's protection. Second, instead of using the trapezoidal seat support, a horizontal bar was inserted between the roll cage to ensure the tallest and shortest riders will fit. Third, the reinforcement bars were installed at the bottom to strengthen the overall structure. Finally, a steel plate was used to attach both the seat support and steering bar to the main boom.
The steering system incorporates side stick steering as shown in this diagram, with a custom turned spindle and steerer to attach to the head tubes on either side of the trike using standard bicycle headsets. The drivetrain uses a SRAM Eagle 1x12 group set to allow a wide gear ratio with minimal complexity. Tensioners are incorporated in several places to route the chain around the frame.